Here in section 10.2, we're going to look at the idea of regression. And regression is going to be trying to come up with an equation of a line that can explain the relationship between the x and the y variables. And so this line, the equation of the line that we're finding, is called the regression line or the line of best fit. Notice that in the equation of our regression line, it uses a hat on top of the y symbol. And if we remember that the y hat is usually referring to a point estimate. In other words, a way of estimating the population parameter y. So in this case, y hat is of course the estimator for the y variable. And it's based on it's computed by using inputs that are from the x variable. And to kind of remind ourselves here, the x is referring to the explanatory variable, and the y is referring to the response variable. So our line of best fit is going to be the one that fits the data most closely. So So I'll say it this way, that the line that minimizes the distance between the points and the line is going to be our line of best fit, and it fits most closely to the data points. So that's why we're calling it the line of best fit, because it's the best line equation of a line that can match the data most closely. And so we'll write it this way. It's y hat equals b0 plus b1x. Remember, b1 is also referred to as our slope. And b0 here would be the constant term that is the y-intercept. So to remind you guys, if we have like an equation of a line, something like this, the y-intercept would be the point where it crosses the y-axis there, so that would be b0. And the slope here would be the rise over the run, right? In other words, the distance it goes horizontally is the run, and the distance it goes vertically between 2 points is the rise, right? I think the rise over the run would be the slope. So let's look at the formulas that we'll use to compute the coefficients b1 and b0 for our line of best fit. So to get the slope, we'll use the correlation coefficient there, right? That's the value of r that we were computing in the previous section. And then here sy and sx refer to the standard deviations of the y variables and the standard deviation of the x variables. So those are both standard deviations. Each corresponding to the y or the x variable. And then for computing b0, the y-intercept, we'll basically take our equation of the line y equals b0 plus b1x, and we'll use the point y bar x bar as the input. And those we're assuming are going to be points that are on the line of best fit. But what are they? Those are actually the means of the x's and the y's. So x bar, of course, is the mean of the x's, and y bar would be the mean of the y's. And since we're assuming here that x bar, y bar is a point on the line, then once I get b1, once I get the slope of our line, we can substitute those values x bar, y bar into our equation of the line, and that'll give us b0, the y-intercept. And just like before, our round-off rule here will be 3 significant digits.